Hello guys, this is Rashmita and welcome back to Civil Center. So, in our previous video, we have discussed about the structural drawing and we have moved to the Excel sheet and we have performed some of the items like piling work and earthwork in excavation. So, in today's video, we will move to further. So, let's get started. So, in our previous video, we have discussed about piling work. We have done piling work and earthwork in excavation for foundation. We have completed up to F4. I think we found the length of this very well and 65. This is, let me show you how it has come. So this is the foundation. This is the brick wall foundation actually of periphery beam. This is the brickwork foundation for periphery wall. You can see this is the we have 10-inch periphery wall at the top and then 15 inch, then 20 inch, then PCC, then 17 inch. So here you can see 0.65. 0.65 where it has come. So from where we have get this 0.665. Actually, you can see this is 20 inches and we have given 3 inches more, so 20 plus 3 6, so 26 inches. So here just we have done 26 inches, so 1 inch is our approx 25 mm, so 26 inches. What 26 inches will do? 26 into 25, so we'll get 650, and that's we'll convert it into meters, so we'll get 0.65 meter. So next we will see the height of the periphery wall. It will provide a foundation. So in this foundation diagram, you can see these are the height of that periphery wall foundation. So we'll have to just add this amount. So we'll get the height of periphery wall foundation. So 5 plus 6 plus 6, 3 and 4. So if we'll add this up, we'll get. So if you'll add these, you'll get 5. You will get 24 inches. So the height of the foundation of the periphery wall will be 24 inches. So here you can simply write the 24 inches. So then we'll have to convert it first. So 24 inches, again it's the same process. We can just 24 into 25. So 600 mm. So we'll convert it into meter. We'll get 0.60 meter, approx 2 feet. So we'll get it approx 2 feet. Generally we take 2 feet. So here you will calculate the quantity. So for quantity, just simply calculate these numbers into length, into the width, and to the height. So here we will get the quantity, and the unit of this we'll get is just we have the for the unit we know we have length, width and height, so it will have cubic meter. So just copy and paste. So we get the unit cubic meter. Next, total quantity by adding 10% extra. So we'll add the simply 10% extra we'll take. So we generally take 10% extra because of the wastage and other. So we just calculate this quantity, just add this, and that quantity will add 10%. So for getting the quantity, we'll just we'll write here sum before we write just bracket and sum, then we'll bracket, we take this quantity, so this quantity, and close the bracket into 1.1. So here we'll get the quantity. Again, for this quantity, we will just write copy, or we can just drag it. We can get unit, that is cubic meter. So next we will see earthwork and excavation of the area including disposal. Sorry, here P is not there. Disposal of excavated earth lead up to 5 meter and lift up to 1.5 meter. Disposed is to be leveled and nearly dressed. So the excavated soil that we have to dispose, if the quantity be within the need of 5 meter and lift of 1.5 meter, so it doesn't cost any charges. But if it exceeds, then we will have to pay for that. So for this quantity, we just simply copy this quantity, because this is the excavated earth. So this quantity will have to dispose. So for unit, we'll just copy this unit. So we are done for disposal, and next we will move to sand filling. Providing sand filling of specified depth for foundations, including spreading, ramming, consolidating, and curing, etc. Including cost and conveyance of labor, materials, taxes, royalty, T&P. So before moving to sand filling, first we will know in which area sand filling will be done. So the first area will be in our foundation, and the second one will be below the periphery wall. Let me show you with the help of the drawing. So in this area is the foundation. In this foundation also we will have to provide the sand filling, and this is the outer portion. This will be the outer portion of the periphery wall. As we know, in this area we have to provide that periphery wall. So inside this built up area, so inside this built up area also we'll have to provide sand fill. Just we'll have, so we can see this structural drawing here. Here you can see this is the periphery wall where we will provide the sand filling, and this is the inside. In this inside of the periphery wall also we'll have to provide the sand filling. And here you can see this is the PPC, PCC. This is PCC. So PCC provided 75 mm, and by mixing we have mixed sand filling. So let us assume also, and already we have assumed in the excavation part. So Here we have provided 100 mm sand filling. You can see here in the Excel sheet, just we have, here you can see 0.1 meter we have provided of sand filling. So it is clear now where we have to do sand filling. So let us see our first part, which is foundation part, or footing part. So we'll have to just see. So we'll have to just see F1, the numbers of F1, F2, and F3, F4. So for F1, we can just simply copy this because we already have the numbers of F1 and F2 foundations. So we just get the numbers of the foundations, footing, sorry, and this is the length and width of the. So this is the length and width of the foundation. So I'll just simply copy this and paste here. So now for height. So we are doing for sand filling. As we know, we have taken the sand filling, amount of sand filling is, so the amount of sand filling is 100 mm. So we'll take simply just we'll take here 100 mm. So 0.1. So we have 0.1 when we'll convert the 100 mm into meter. So we'll just calculate this quantity numbers into the length and width into height. So we'll get this quantity, and for unit we know when we have length, width and height, our unit will be cubic meter. So I'll just copy the cubic meter and we'll paste. So likewise, in all footing we have 100 mm of sand filling. So we'll drag this and just simply drag this also quantity and quantity section. So we'll get the quantity of F2, F3 and F4. For unit also, unit will be same for all. The unit will be same for all the footings. Now we will come to the periphery wall. This section. Now we'll have to do this section. Here you can see this is the periphery wall. So below the periphery wall, we'll just provide the sand filling. So brick foundation or brick foundation. Here in number 4, I will write 1, and we'll just merge this because we'll just merge this column and this column. We'll just merge this row. So we need this length, the outer line. We need the outer portion for the sand filling. So we'll just select this and just list. We'll do list and I enter. So here you can see this is the perimeter. We need only the perimeter, not the area, as we are doing the in foundation part only. So 51 point. So for in winter, it will be 51 point. For sand filling also we know for sand filling also we know it is 0.1, which is 100 mm, and we just calculate this. So we have calculated it, but here one thing is missing. This length we have taken the perimeter, not the area. So we'll have to convert the cell as we have taken only this area, not the whole portion. So for width we need this portion. As we are doing sand filling, so we need this portion. How we'll find this? We have already find the 20 and 3 plus 3 26, 26 inches. So for 26 inches, we have already written as 26 inches is equal to 0.65 meter. So we'll write here simply 0.65 meter, and we'll have to calculate these, all these, is length, width, and height. So we'll calculate the numbers into length, into width, into height. So we have just calculated the quantity of the brick foundation and filling. So for the unit, we know this unit will also be in cubic meter. Now will move to the inside of the periphery wall, which is the built-up area. Let me show you. This is in this area. I will do this and filling. So for the inside of the periphery wall, we'll just need this line, inside line. So I'll get this area. Simply we'll select this line, the inner line, and we'll calculate the area. LIN, and we have the area. So why we have taken here area? Because we have used and filling in the whole part. So that's why. So here the area is 137.82. So simply we'll write here in the number section we'll write 1, and then in length 137.32. So for the height we'll just move to our structural drawing. Here you can see this is the ground level. This is our ground level. Below ground level we have excavated for sand filling and PCC, that is 75 mm and 100 mm for sand filling. So above ground, so you can see this in above ground we'll have to fill 1.2 1200 mm. This is our plinth level. So we'll have to do sand filling up to this level. So simply we'll write here 1200 mm. We'll convert it into meter. So 1.2 meter. And again we'll have to calculate the quantity. So just number into this area into the height. So for quantity, we'll just drag this and simply we can get the quantity that is in cubic meter. So after calculating the quantity of inside periphery wall, that is in the built-up area, and we'll have to just do reduction, because here you can see in this height the footing height is also included, that is 350, and footing height is also included, and you can see in this built-up area this footings also, these footings are also coming, so we'll have to just deduct this amount. We'll have and we'll have to deduct this footing, and in this also you can see these plinth beams. Plinth beams are also coming. So these you can see these are the plinth beams. So we'll have to also deduct this plinth beam. Okay. So first deduction of footing. So how will you know? So how we will know that which footing and how much we'll have to deduct for footing? So we can see in the structural drawing. So how we will know that which portion is covering in up to this area, which footing is coming full, which footings are coming full and which footings are coming half under this area. So we'll just simply copy this and this, and we'll paste here. We have already copied this footing foundations layout, then we'll just paste here. So we'll have to just simply select this and this line. After an inner line, yes, all the lines are selected, and simply copy this with this corner. We just paste here. You can see now this footing F1, F2, and this F2 is coming fully. These footings are coming fully into the built-up area, and where we have done sand filling, and these footings are coming half. So we'll take it. So we'll calculate it as a half. So why we are deducting this footing? Because we have already done sand filling here, and we have done sand filling in this area also without deducting this amount. So if we will not deduct this amount, the amount of footing, so it will be get doubled, the amount of sand filling. So that was the purpose of deducting the amount. So let us just know this area. F1, that is 66. This is in so 0.66 meter. So we have one full F1, and two F2. So in the Excel sheet, we'll just write here one numbers in the number one, and we'll start bracket at 0.66. So we know the rectangular footing area, which is 0.66 meter. Similarly, we'll calculate this area also, this footing also. So with the same process, we'll calculate the area. You can see the area. So for this footing also we know the area. So we'll simply write here in the Excel sheet 1.14 meter. So here first we'll write the complete ones. Then in second layer we'll calculate the half part portion of the footing. So bracket 0.68 into 1 plus 1.14 into 2. I think 2 footings are come full. So bracket 2 enter. Yes. Here you can see F2. We have 2 F2, which is completely so here you can see this is the 2 F2, which is completely coming in this built-up area, and this is one F1. So we have calculated one F1 and 2 F2. So for the height, we know the footing height is 350 mm. Here we can see the footing height is 350 mm. So we'll just convert it into meter and we'll write it in the place of height. In this footing schedule, we can see this F1 has 350, height the depth is 350, and for F2 which is 400. So for F2 this is 400, and for F3 350, F4 350. So now in the place of height, simply we will write 0.35. Here we have taken only the covered one, so let us count the how many half footings are coming in the built-up. So for F1, 1, 2, 3, 4, 5, 6, 7. So we have 7 F1 in the outer portion. So in this area, you can just write 0.66 into 7 into 0.5 plus so how many this shape is coming, this trapezoidal. So 1, 2, 3 for F2. I think only F3, one F2. one F2 is at the outer portion, and one F2, and 1, 2, 3, 4. 4 F3. As we know, only the depth of F2 is different. All the rest are 350. So now by calculating this, we get the amount of the deducted footing amount. So now we'll come to the Act 2. So 1, remember we'll write 1. So for F2, as F2 is at, so F2, the depth of the F2 is different. So we'll calculate the F2 separately. So here we'll write the F2 portion. So F2, you can see we have 1, 2, 2 whole F2, and this 1 half F2. Yes, 2 whole F2 and 1 half F2. So in the Excel, we just is equal to, and that's that. 2 whole F2 and 2. We know the length of the that footing, so 1.14 plus we have 1 F2 at the outer portion, so 1.14 into 1 into 0.5 bracket. So in the height place, we will just simply write 0.40 as the depth is 400 mm. So for this, we'll calculate quantity into this quantity into this. So likewise, we'll do for the lower one also. But here we are doing reduction, so we'll add minus sign. Yes. Now we have we got the quantity in negative, so the unit will be the in cubic meter. So we'll simply copy and take this one. So for being here, we'll write simply one numbers, and in length we'll calculate these lengths. We'll have to calculate these lengths, the internal beam length, internal as well as this. So we'll calculate these lengths. So first is you can see, if you will see, you can see this length plus this length. So 16.209, we'll have 16.209 in meter. Likewise, if you will exclude this, then we'll have to calculate this length, this plus this plus this and this length. Wherever we have beams, we'll have to add this length. As I have said, this length will be 16.209. Likewise, you can calculate this length also. This horizontal line For horizontal lines, you can see here, these are the measurements you can take the help of measurements. These measurements you can calculate this quantity. So after calculating the quantity, somehow you'll get the length approximately 109.27. So in the width section, we'll just we can see here in the width section, here, this is the plinth beam, and you can see the size of plinth beam, which is 250 to 300 mm. So simply we'll write 250 for in meter, and here 300 for 250. So simply calculate this amount. And for unit, we'll simply drag it per cubic meter. So these are the deducted amount. Now for total quantity, we'll just sum it. Sum here we'll give bracket. So we'll drag it up to here. Bracket close into 1.2. Bracket close. So this is the quantity. So this is the quantity. So we'll copy this unit. So that's all for today's video, guys. We'll continue it in our next video. Till then, thank you and have a nice day.